So yesterday, just at the very end of class, I introduced how these climate graphs work. Okay, so I'm just going to quickly review that. From a climate graph, you can read directly on the graph what the temperature in a certain month is, the average temperature, okay, and the average rainfall is per month. All right, and that can tell us a few things about where that particular place might be, and from there, what factors might affect its climate, okay, and how they would affect it. So, for example, if I'm looking at this one here that says it's located in Manakwari, New Guinea, okay, which is a place that is literally right on the equator, okay, it tells me that over the course of the year, the temperature basically doesn't change. It's 31 degrees, or sorry, it's 25 degrees, 26 degrees every day, basically. Okay, now it's probably not 25, 26 degrees every day, but on average, that's what it looks like each month. Okay, so it's a pretty good bet that they don't have a winter and a summer, yes? Okay, now, is that indicative of a place near the equator? Okay, because near the equator, what is basically zero for you? Which factor affecting climate would be a big goose egg for you? The biggest, most important one? Latitude. Okay? The latitude of the equator is 0. Okay? It is literally the middle of the earth. Okay? And that means that if you are anywhere near the equator, in fact, if you are within 23.5 degrees north and 23.5 degrees south latitude of the equator, you effectively have no change in the intensity of the sunlight that is received. Okay? The tilt of the earth doesn't make any difference for you. All right? And that means that your temperature is not going to change because your input energy, the sun, is always the same. Right? Now, near the equator, there are going to be some places that are going to be like this, that are going to get fairly heavy rain all year long. And there are going to be places like the Sahara Desert that's also right on the equator that basically get no rainfall all year long. Okay? And that's okay. We can look at the graph and we can read it and say, well, this place gets a lot of rain. It's probably near a place where, winds blow off the ocean and they're carrying a lot of moisture, or maybe there's a set of mountain barriers nearby that's going to cause the rain to fall on that particular area, or something like that. Okay, does everyone kind of follow? Those are the conclusions we can kind of draw from a graph like that, even really without knowing where it is. Okay, our next graph shows something that isn't near the equator. Okay, what we would call a mid-latitude city. So it's about halfway up north-south in the United States. Okay, so Nashville, Tennessee. And we can see that the temperature line is a bell curve. That is, it is low in the winter months and high in the summer months. So obviously this place gets summer and winter, right? And that would tell us that if I see this, that it must have a latitude that is not near the equator. Okay, now it's also not near the North Pole. How can I tell that? How cold is the coldest month according to that graph? Okay, temperature's on the right-hand side. Coldest month is 6 degrees plus 6 degrees. Okay, is that very cold? I would love it if our coldest month was only plus 6 degrees. Okay, that would be awesome, except it's not. It's minus a million. Okay, but yeah, we can tell that this is, not near the equator, but we can tell it's also not near the pole based on where that curve sits, right? You don't get, plus 28 in the summertime in Alaska. Okay, you can't be near the North Pole and get that kind of temperature. Now, if we're looking at the last graph, okay, we can see that the temperature is still a bell curve, which tells us it's not near the equator, right? And it tells us that it's also fairly far from the equator because the winter months are significantly colder than they were on this one. Okay, so the lower that bell curve goes, the further north that place is. All right, that's something that we can interpret from the graph. Everybody okay with that idea? Now, are there things that could be misleading about that? Like if I looked at a graph of Vancouver, for example, okay, would I still get a bell curve? I would, but it's going to be considerably higher than Calgary's, even though they have similar latitudes, because Vancouver is near an ocean. right? So all of those little things, those factors that affect climate, can be read essentially from the climate graph. Okay, and that's what you're going to be asked to do on your unit exam and final exam. I'm going to put a climatogram on there, okay, and I'm going to ask you, what part of the world does this come from? Okay, I'm going to ask you specifically what biome. We haven't gone over the biomes yet. You probably went over them at some point in junior high science, like the Arctic tundra and the tropical rainforest and all of that. Okay, we're going to go over those again, but I'll ask you, what biome does this climate graph come from? And you would have to explain to me, well, on this climate graph, let's say it looked like this one, okay, the one on the left, you would say, this must be near the equator because the temperature line doesn't fluctuate and that means there's no season, so the latitude would be low. Okay, this place also gets a lot of rainfall, which would build fairly thick, kind of, luxuriant vegetation. So it's probably a tropical rainforest. Done. You showed me I can read the climate graph, I understand what it says, and this is what it fits with, and that's why I think that. Okay, everyone kind of follow? Okay, now looking at the precipitation lines, okay, can they tell us a lot? Okay, they can tell us this place is pretty wet and this place is pretty dry. Okay, now the other thing we have to look at here, we're fortunate. All of these climate graphs have the same scale. Is it possible for me to make a desert look like a tropical rainforest? I can put them side by side and they can look, the desert can look super wet. All I have to do is mess up the scale. Okay? If I decide, well, I want someone to be able to see my precipitation lines really well, instead of making it look like there's basically nothing, I'm just going to make the rainfall scale silly. Okay? And now all these bars go right to the top. Well, then it makes the desert look like it's really wet next to something else. So you always have to look at the scale for both temperature and precipitation, because not every climate graph is the same, and sometimes the length of those bars can be misleading if you don't look at the scale. Okay? All right, everybody good with that? Okay, so here's what we're going to do for today. We're going to look at this climate graph activity. Okay, and what we want to do is we're going to look at the various climate graphs, and we're going to see if we can put them in groups together based on their similarities. Okay, based on, like, do they have a similar shape? Are they showing similar climate? Right, based on just their shape. Okay, so if I'm looking at these two graphs on the top right now, all right, their precipitation scales are pretty close to the same, right? They go from 0 to 180, 0 to 160. So they're representing pretty similar amounts of rainfall. Okay? And the pattern of that rainfall is fairly similar, right? It's lower in the summer, higher in the winter. Okay? And their temperature lines, well, their temperature scale is a bit different, but their temperatures are still very close. Okay? They're between -4 and -6 in January, February, -4, -5 in January, February. Goes up in the summer to about 16, 17. Same with this one, 15, 16. Can I say that these two places have very similar climates? Should I put them in the same group? Okay, now look at where they're from. One's Halifax, one's St. John's, Newfoundland. Do those two places have pretty similar climates for the same reasons? Yeah, they're both on the Atlantic coast. Okay, so are the factors that affect their climate going to be very similar? They're both pretty far from the equator. They're both at sea level. Okay, that's latitude and altitude taken care of right there. Okay, they're both near a large body of water. They would both be affected by the same ocean current. Okay, that would be coming the Labrador current and the Gulf Stream. Okay, those two would certainly affect them in the same way. Okay, so yeah, we can certainly say that they have a lot of factors that affect their climate in common, so they should go in a group together. Okay, everyone kind of follow on that? Right, that's what I want you guys to do right now. Okay, I want you guys to get together with, let's say, 2 or 3 other people, okay, and see if you can take these climate graphs, you can look at them on your phone, okay, see if you can take these climate graphs and put the ones that look alike together. I would say at the end of this, you should probably have between 5 and 7 groups. Okay, so 5 and 7 different climates, basically, that you'd be looking at. All right, I'm gonna give you guys about, let's say, 15 minutes or so to come up with some groups, and then I'll come up with some groups and we'll compare. Okay? All right. All right, so let's start having a look at the groups that we've made up and kind of why. The reason we want to do that is this is kind of the reverse of what I'm going to ask you to do on your unit exam. Okay? On here, I gave you the climate graph, said put them in a group and figure out what the factors affecting climate would be. Okay? On your unit exam, I'm going to give you a picture of the map of Canada and say, this city, tell me what the factors affecting climate would be and predict the climate. Right? So instead of giving you the climate and saying figure out why, I'm going to give you the city and say predict the climate. All right? Everyone kind of follow me there? All right, so we got to think about the factors that affect climate here. So probably all of you did this. I would say that these three cities, for reasons that are fairly obvious, should go in a group together. Their climate graphs are virtually identical. All right? And then, as common sense is, kind of want to do, is I look at where they are. Halifax, St. John's, and Charlottetown, okay, are, well, kind of close to each other, okay, in terms of geography here. So we're going to be looking at over here on the east coast of Canada. And it's not showing me the city names, but okay, so Charlottetown would be right here. Oh, there we go. Now we're getting PEI on there. Okay, we've got St. John's, right, on in Newfoundland here, and it is right here out on the rock. Okay, and we also have Halifax, okay, which is in Nova Scotia, and it's just a little bit north of Truro. For some reason, it's not showing up on there, but okay. So are they all fairly geographically close? Okay, so if I'm looking at those three places, do they have a similar latitude? All right, so that's the reason why their temperature line is very similar. Okay, they're all at the same altitude, sea level. Right? They are all, close to the Atlantic Ocean and affected by the same ocean currents, as we kind of said before. So if I was explaining why I put those in the same group, or if this was on a test explaining what the climate of that city would be like, I would first say its latitude is pretty far from the equator, so daylight's going to vary, there's going to be significant seasons, all the stuff I see on the climate graph. Okay? Rainfall is going to be fairly high because there's a source of moisture, the ocean, right next door. Right? Ocean currents in that area flow out of the north, so the water will be colder, okay, losing its ability to moderate temperature. Okay, something along those lines. Everyone okay with that idea? All right. Then, if I'm looking at my next group, okay, my next group just had Prince Rupert in it. Okay, I don't know how many people put Prince Rupert in a group with anything else. Okay, but I looked at that, and the big thing for me was the rainfall. It's stupid. Okay, there's nowhere else in Canada that gets rainfall like that. The next wettest place was Victoria and Vancouver, right? And they were like less than half of that. So it didn't really feel like, even though the temperature line was similar to those two, that I could put it in a group with them. So it ended up in a group by itself. There just wasn't anything else that really fit with it, right? So if I'm looking at where Prince Rupert is, okay, it's quite a bit north on the coast on the west coast. So there's Prince Rupert, okay, way up near the top. Yeah, it's quite a bit north of Vancouver and Victoria, so yeah, its latitude is different. All right, it's right on the ocean, but it's quite a bit. It's like in this little inlet here, right, and that's maybe going to produce more moisture, something. Okay, it's closer to the mother low, which is probably a big reason why. Okay, it gets so much precipitation versus Vancouver and Victoria. Okay, so I put it in a group by itself because it seemed to have similar factors, but the rainfall just said it needed to go by itself. Okay, and then the next group I called Northern Continental. Okay, and Northern Continental, for me anyway, had 5 cities in it. Okay, and those 5 cities were Whitehorse. Okay, looking at it, its precipitation bars show that most of the precipitation is in July, August, September. Okay, the temperature gets pretty cold in the wintertime and not terribly warm in the summer. and that seemed to fit with a few of the other ones. Okay, looking at, let's see here, at Iqaluit, it was kind of similar to that. The scale was a little bit different, but got pretty cold. Precipitation was January, August, September. Okay, looking at Churchill, it was also, but very different scale, but still similar numbers, gets pretty cold. Okay, January, August, September, highest precipitation, similar numbers. Okay, and then looking down at Inukjuk, okay, similar, July, August, September, wettest months, gets pretty cold. Okay, so that fit, I thought, together. Hopedale also, while its precipitation was a bit more uniform, it didn't really fit anywhere else. It could have maybe gone by itself. Okay, but I thought it fit pretty well with those other ones. Okay, and then I would say that Resolute needed to go by itself. Okay, and that's simply because its precipitation was so much lower and its temperature was so much lower, okay, than the other places. And if we're looking at the map again here, okay, we're looking at some places that are pretty far up there. Okay, Resolute is, I think, way up here. Okay, like it is basically the northernmost habitated place in Canada, okay, which makes it quite a bit different than places in, let's say, Manitoba or Nunavut, okay, or places like that. So I just felt it needed to go somewhere else because its latitude was so much different than everywhere else. So you guys following the logic pattern we want to be able to show when we're explaining that on a test? Okay, because like I said, on a test, I'm picking a place in Canada, and you've got to tell me, okay, here are the factors. Should latitude be one of them? No matter what city I pick? Okay, altitude also a good one? Okay, and rain, like mountain shadows or, rain shadows, mountain barriers, okay, things like that. All right, and then my next group, I called Canadian Shield. I think I walked around and saw some people had called it like Central Canada, okay, and that would be Toronto, Montreal, and Thunder Bay. Okay, they had pretty similar climate. So there's Thunder Bay, there's Montreal. Like certainly their precipitation lines are a little bit different, but not significantly so. Okay, their temperature lines are virtually identical, right? And if we're looking at Toronto, was on the previous one, or was it? Yeah, right there. It had a very similar shape. So I put them in a group together, and then obviously if we look at a map of Canada, they're all in the Canadian Shield. They're all about the same altitude, about the same latitude, okay, close to the Great Lakes, stuff like that. All right, and then obviously the prairie cities, so Winnipeg, Regina, okay, Edmonton, Calgary, and Medicine Hat, I thought all went together. Their climate graphs all had the double bell curve. So the bell curve for precipitation and the bell curve for temperature. Numbers were about the same, okay, for both precipitation and temperature, right? All affected by the same things. They're fairly high altitude, fairly similar latitudes, and they're all on the leeward side or the east side of the Rockies, where there's not going to be a lot of precipitation, so they're going to have drier climates with more severe fluctuations between summer and winter. Okay. We already talked about Resolute. I called that the polar climate. And then I looked at just the west coast. I had Vancouver and Victoria in the same climate group. Again, lower latitude than Prince George, okay? And so they had lower precipitation. Okay, so we're kind of following what we need to be able to do. Okay, because that's exactly what I'm going to ask on your unit exam. Here's a map of Canada. I pick a city at random. It's a different city every year. Okay, and you have to tell me, all right, this city is the main factors, and I would say pick 3. Okay, and a question like that, it's odd that you guys aren't writing this down because I'm kind of telling you how to answer this question on the test. Okay, so on that question, pick 3 factors. The 3 you think are the biggest, okay, that affect that particular city's climate. Right? Tell me what they are, how they affect climate. And then for 2 marks, you kind of predict what that climate will be. So for example, if I picked Okotoks, which, spoiler alert, I'm not going to, okay? But if I picked Okotoks, all right, I would look at this map and I would say, factor number 1, latitude. Okotoks is quite a ways from the equator. I think our latitude is like 52 degrees north, okay? Something like that. So we're quite a ways from the equator. That means the amount of daylight we receive changes not only in length, but in intensity throughout the year, leading to distinct summer and winter. The second factor, I would say, affecting its climate is the presence of mountain barriers. We are right behind the Rockies, okay, which is going to produce things like Chinooks and reduced rainfall. So this will be a fairly dry climate. Okay. And I would say the third factor, you could make an argument for altitude, certainly. Okay, we're at 1,100 meters above sea level, so that's going to mean it's a little cooler here. Okay, or you could say proximity to oceans. We're not near one. Okay, and that means we have nothing to regulate our temperature, so we can have pretty wild fluctuations on both daily and seasonal basis. Right? So you can make an argument for either one. But that's what I'd be looking for on a 5-mark question, okay? 3 marks for the factors that affect the climate and how they do it, okay? And 2 marks for predicting what that climate would be like. Okay, so since we got time, I want you guys to try and answer this if I give you a city right now. So let's say, Moosonee, Ontario. This is a place where they've got a lot of wildfires going on. Town was evacuated. So there's kind of triggered in my mind. Okay, so Moosonee in northern Ontario. So it's right here. Okay, I want you to tell me 3 factors that would affect its climate. Okay, so it's right here at the bottom of Hudson Bay. So I'm just going to zoom out so you can see a little bit more here. Okay, so it's right there. Zoom out a little bit more. Okay, so 3 factors that affect climate, how they would affect it, and then tell me what you think the climate would be like. Okay, so there's a climate graph for Moosonee, Ontario. Okay, so we're looking at precipitation. The driest month is about 26 millimeters of rain, okay, but the wettest month is over 100, and it goes up through the summer and fall, and temperatures, okay, goes up to over, well, the daily highs are over 20, but the average temperature is about 15, okay, 16 degrees, okay. It's a reasonably wet climate, certainly more precipitation than here, all right. What would the factors be that we picked? What's the first factor we should pick anyway? Latitude, yeah. Moosonee is pretty far from the equator, okay, fairly far north, and as we can see on this climate graph, it has distinct summer and winter. Okay? It gets significantly colder because the amount and intensity of sunshine fluctuates throughout the year. Okay, that's what you can write basically for any city, okay, when you are talking about latitude. It's either near the equator, or the intensity and amount of sunlight doesn't fluctuate, or it's not. Okay, and then for this, okay, we could say that because it's near the Hudson Bay, okay, there's a fairly good chance of getting a lot of moisture coming in off of that large body of water. I would say your second one should be proximity to large bodies of water. Okay, it is right on the Hudson Bay. All right. being near bodies of water, okay, can certainly help to bring in large amounts of moisture, which accounts for that precipitation. But because the Hudson Bay, and I don't know if you knew this or not, the Hudson Bay does freeze over, okay, most years. Does that limit its ability to regulate temperature? Okay, which is why we see that the temperature here is not regulated by the proximity to the ocean. Okay? The ocean is basically just, or the Hudson Bay is acting as a source of moisture, but not temperature regulation. Okay? And then I would say altitude, okay, pretty close to sea level, right? So that could make it a little bit warmer there. I think you could also maybe make an argument for being, you know, away from any major ocean currents, okay, or something like that. All right, that's what we're going to be looking to do.